Mr. Mack here. We're going to do the 4.5 practice solutions for isosceles and equilateral triangles. Number one, we have an equilateral triangle, and we know one of the sides, so that means x has to be 10, y plus 3 equals 10, so y equals 7, x equals 10. Number two, we have an isosceles triangle. We have one pair of congruent sides. So in an isosceles triangle, we know that we can set those expressions equal to each other. So we're going to say 2x minus 9 equals x plus 5, and just solve. Subtract x to both sides. Add 9. So we get 14 for x. And that is our solution. So we substitute 14 back into the original problem. We're going to get 2 times 14 minus 9, which is 19. And if we put it in for x on the other side, we get 14 plus 5 equals 19. That checks. Number three, this yellow triangle is also isosceles. It's got two congruent sides. So we know that the base angles of an isosceles triangle are going to be congruent. So we just take this expression, set them equal to each other. 6x minus 1 equals 77. Add 1, divide by 6, and 6 goes into 78 13 times. Let's substitute the 13 back in. 6 times 13 is 78. Subtract 1 is 77. Same as the other base angle. Green triangle number 4, also isosceles. Set the two expressions equal. Get your like terms together. And don't forget to write the problem down correctly. So we're going to get 1 for x. And if we substitute that into our equation, you got it, Never?
Yeah, sorry, I didn't want to interrupt you.
That's all right. Just put it on the video.
Okay.
We get, just talking to Mrs. Mack, 22. It is pouring outside right now. Canceled a lot of public schools. Okay, so we have this pink now triangle here, and we got congruent base angles. So if base angles of a triangle are congruent, then the triangle is isosceles. So we can set these two expressions equal to each other. 5y equals 15, divided by 5, y equals 3. And we can substitute this. 5 times 3 is 15, minus 2 is 13. And it checks. Number 6, we're given all three angles of this interior angles of this triangle, but we got the base angles here congruent. So how about we write an equation to solve y first, since we've got the base angles, and then we can get x. So we solve for y here with our expression. I got to back up here. What did I do? 8y minus 16 equals 72. We're going to add 16, and that gives us 88, and y equals 11. Now, if we know that 9x plus 72 plus 72 is 180, triangle interior sum theorem, and we can solve for x, and we get 4. So if I put 4 into x, I would get 9 times 4 is 36, and 36 plus 72 is 180. Check. Now, number 7, we've got L1 is parallel to L2, and we got a bunch of, well, we have one angle given is 134, and we have two congruent sides. And so we are going to start off with, I mean, we can puzzle this out and find it any way we want, but I know that A and 134 is a linear pair, so I can just subtract that from 134 from 180. I've got some alternate interior angles here. I have base angles of a triangle congruent. I've got some corresponding angles here, so C is going to be 46. D here is a linear pair with the 46, and so that gives me 134. I've got this whole big angle right here for F, and that is going to get divided, bisected. So if I got 134 and divided by 2, it gives me 67. So G corresponds with F, so they're going to be congruent. E is going to be alternate exterior with angle C, so that's going to be 46. And then B is going to be 180 minus the two 46s there, because we've got three angles that are supplementary. All right. Okay, 16 is triangle ABC isosceles. Explain your reasoning. All right, so we've got segment BD is congruent to itself. So why am I doing this? We've got these two triangles, ADB and CDB, that looks like we might be able to prove that they're congruent. So let's see if we can use a triangle congruence here. I know that angle BDC is 90 degrees. It's a linear pair with angle BDA. So those angles are both going to be 90. And triangle ABD is going to be congruent to triangle ACB because of angle side angle. So we're already given those top two angles were congruent. So then I know AB is congruent to CB because that is the corresponding parts of congruent triangles are congruent, CP, CTC. And that's the definition of an isosceles triangle. If we have two legs are congruent, it's isosceles. So that proves that. So 16 is done. 17. Triangle EQL is an equilateral triangle if segment EU bisects angle LEQ. Find. All right, so bisecting means cut in half. So we've got 60 cut in half. It gives us some 30s. And we know that when we bisect an equilateral triangle, we get a perpendicular bisector. So we're going to get half the lengths of 4. And that's it. You guys kind of figure that one out. Determine the following statements are always, sometimes, or never true. Base angles of an isosceles triangle are congruent. Always. Base angles of isosceles triangle are complementary. That would be sometimes. Complementary means they add up to 90. So sometimes the base angles could be 90 if it's a 45, 45, 90 triangle. 20, base angles of an isosceles triangle can be equal to the vertex angle. Sometimes, if we have an equilateral triangle, the base angles could be equal to the vertex angle. 21, base angles of an isosceles triangle can be right angles. No, it can never be, because the base angles are both 90. We would get parallel sides, that we would never get an intersection. There is no vertex at the top. That wouldn't work. Base angles, number 22, of an isosceles triangle are acute. That's always have to be acute. Got to be less than 90. All right, let's see, proof here. we've got an isosceles triangle CIS, and base angles of angle C and SIO is the angle bisector. Okay, so we can write the given statement. And what does the base angles theorem tell us? Right, it says that angle C and angle S are congruent, right, for a isosceles triangle. So we got another pair of congruent angles that we know. CIO, angle CIO and SIO are congruent. That's because we already were given that it's a bisector. Segment IO is a bisector, so those have to be congruent. That's the definition of angle bisector. And these two triangles right here share something. They share that center segment IO, so we can say reflexive. And we've got AAS, angle side property. And then we know all the corresponding parts of congruent triangles are congruent. And we also know that angle IOC and angle IOS are also congruent because of CPCTC. And we know that those two angles are supplementary. That's a linear pair. It's the definition of linear pair. So if they are supplementary and congruent, then that means they are both 90 degrees. Seems like we're writing a lot of steps here for these reasons, but that's what we do. So segment IO is perpendicular bisector. That's the definition. We've already proven that it bisects CS and that the angle is at a 90. So that's the definition of angle bisector. That's it. We finished this 4.5 practice in record time. See you all later.